Now, welcome to section 2 of Nyaga secondary school examination paper. We are going to start right away from question 17. It is a question on equations of straight lines. Questions of straight lines. So let us start with 17. Now, the question reads, find the equation of a straight line which is perpendicular to 3y minus 5x, which is equal to 5, and passes through the point of intersection of the line 2x plus y equals to 5, and x minus 2y is equal to 0. So using the two points of intersection, we want to, the two equations, we want to look for the point of intersection. We're going to have the two equations, which is 2x plus y is equal to 5, and x minus 2y equals to 0. So we form the two simultaneous equations and we solve by elimination method. We can eliminate y by multiplying by 1, multiplying by 2, so that we have 4x plus 2y is equal to 10, and x minus 2y equals to 0. So we now subtract, so we shall have 5x is equal to 10, we divide by 5, divide by 5. So x will be equal to 2. That will be the value of x. Then we look for the value of y. So using the second equation, x is 2, so 2 minus 2y will be equal to 0. So we shall have negative 2y is equal to negative 2. Divided by negative 2, divided by negative 2. So y is equal to, so xy now becomes, x is 2, y is 1. So you have the point be 2, 1. Now that the point of intersection, now we look for, now using the equation 3y minus 5x, we can make it in the form of y equals to mx plus c. So we shall have 3y is equal to 5x plus 5 plus 5. So we divide by 3, divide by 3, divide by 3. So y will be equal to 5 over 3 plus 5 over 3. Sorry, this is x. 5 over 3x plus 5 over 3. So our m1, gradient 1 is equal to 5 over 3. Now, perpendicular line, that means our m2 will be the negative reciprocal of m1. That negative reciprocal now, 3 over 5. Now we have xy, we have 2, 1, the point of intersection, and we have the gradient of the perpendicular, which is negative 3, 5. Negative 3, 5. Now, we can use the 3 to now find the equation. Now we take change in y over change in x, so y minus 1 over x minus 2 gives us negative 3 over 5. gives us -3, 5. So it was multiply, so we shall have 5 into y minus 1, which is equal to -3 into x minus 2. So 5y minus 5 is equal to -3 x plus 6. So 5y is equal to -3 x now plus 6 plus 5. So I divide by 5, divide by 5, divide by 5, divide by 5. So y will be equal to now -3 over 5x plus now 11 over 5. So this is now the equation of our perpendicular line. Sorry, the straight line which is perpendicular. Now, a straight line y equals to 2 over 3x minus 2 over 3 meets the x axis at point T. Determine the coordinates of T. We know that at x intercept y is equal to 0. X intercept y is equal to 0. So that when y is 0, so that we shall have 2 over 3x equals to 2 over 3. So we multiply by the reciprocal, 3 over 2 times 3 over 2. So they cancel out and x becomes now 1. So they want the coordinates. So coordinates y is, remember y is 0 and we have x as 1. So x is 1, y is 0. So these are the coordinates. The coordinates 1, 0. Simple as that. Then determine the acute angle between the line y is equal to 2 over 3, x minus 2 over 3, and the x-axis. The acute angle. Remember, we know that tan theta is equal to gradient. And in this equation, our gradient is equal to 2 over 3. Therefore, tan theta is equal to 2 over 3. And how do you find theta? To find theta, we simply find the tan inverse of 2 over 3, which is 0.6667. 0.667. And therefore, our value of theta will be equal to 33.69. 33.69 degrees. Now that will be the value of angle theta. Then find the y-intercept of the line. Y is equal to 2 over 3x minus 2 over 3. And we now find the y-intercept. Now at y-intercept, we know that x is equal to 0. Therefore, y, using the equation y is equal to 2 over 3x minus 2 over 3. You know that x is 0, so y will be equal to 2 over 3 times x, which is 0, minus 2, 3. Therefore, our y will be equal to, that will be 0, so negative 2 over 3. Negative 2 over 3, that will be the value of y. So that the coordinates now, coordinates will be equal to x. We know that x is 0, but y we have it as negative 2 over 3. So these are going to be coordinates for the y-intercept line. So that is how we get our total of 10 marks in this question on straight line. The first 5 marks, and then 2, 2, then 1. That is how we handle that question. Then we move to the next question. And question number 18. While designing the water circulation system, planners of an estate used assumption that each housing unit in the estate will require at least 0.32 cubic meters of water pipe per day. To satisfy this need, they are to use water pipe of radius 8 centimeters to distribute the water. The water will be flowing in the pipe for only 14 hours a day at the rate of 24 centimeters per second. Now determine the amount of water to the nearest liter supplied in 1 hour. Amount of water supplied in 1 hour. So the pipe, you can illustrate a pipe, how it looks like. This is how the pipe looks like. Okay. So the radius is equal to 8 centimeters. It is the radius. Now we have supposed, first of all, to look for the volume of the flux, the volume of the flux. So look for the volume of the flux. This is given by cross section. Cross section times now velocity area. So we shall have 22 over 7, the area, the circle, times radius is 8, times 8, then times now the velocity area, which is 24 centimeters second. Now, this one will give us 4,827.43 cubic centimeters per second. That will be the volume of the flux. Volume of the flux. Then we can now convert that one to minutes. Now, no, this is now the volume. We now divide by 1,000. That is now times, so we shall have 4,827.43 divided by now 1 million. Then times now 60. That is 60, that is in 1 hour, that is 60 minutes. Then times 6. So we shall have 17.3787 cubic meters per hour. That will be per hour. Then we know that 1 cubic meter is equal to 1,000 liters. What about now the 17 17 meters cube? That will be 17.3797 3787. This one we shall multiply by 1,000, and therefore we shall have 17,378.7 liters. That is going to be the answer now. The amount of water in liters, that is in liters, supplied in 1 hour. So we shall have that is 17,378.7 liters. Then you get your 3 marks. Then what is the maximum number of bus housing units that can be supported by the water circulation system? Assume that a housing unit requires at most 0.32 cubic meters water supply per day. Now, we know per hour we are having 17.3787 cubic meters hour. So we shall multiply by, let's say, what is the maximum housing units supported with now water per day. So we multiply by now the 14 hours. Then we shall have now 243.3018 cubic meters. Now we divide by 0.32 cubic meters. This one 0.32 at least. At most, they said at most 0.32. So cubic meter goes with that. So that we remain with 760 housing units. So we shall have at most 760 housing units that will be connected with the water. Now, each housing unit will pay a flat rate of 280 per month for the supply of water. If the number of housing units in the estate is to be maximum and all end up being occupied, calculate the amount of money that will be collected in a month. So that one will be easy. The cost, we know that we have 760. The maximum is 760 houses, and each house is paying 208 shillings. Therefore, the amount of money in Kenyan shillings that will be collected will be 212,800 shillings. That's simple. It will be the amount of money that will be collected. So simply take the number of houses, which is 760, times each amount of money to be paid. Then D, the maximum number of housing units were constructed and all got occupied. The estate ended up using an average of 0.35 cubic meters of water per housing unit per day. How much longer was the water pumped per day to satisfy the estate's water demand. Now, the new demand is going to be now, the houses are going to be, they will remain to be 760 times the new demand, which is 0.35. Therefore, we shall have 266 cubic meters. That is the new demand. We know that time is given by volume over now flow rate divided by the flow rate. So we shall have the volume, which is 266 cubic meters. Then we divide by the flow rate. The rate of flowing is 17.3787 cubic meters per hour. So the cubic meters, it cancels out, so that we have now the 15 hours, 15.306 hours. Remember, we were only using 14 hours. Therefore, we're going to have our 15, this will be 15 hours and 18 minutes. This is how long it's going to take. Then we subtract the original hours, which were 14 hours. It is 00 minutes. So we shall have 1 hour and 18 minutes more. So this is how longer it's going to take to satisfy the demand of the estate. It will go an extra of 1 hour and 18 minutes for the new demand. So that is how we get our 10 good marks for question number 18. So we can move to question number 19. They are saying the equation of a curve is y is equal to x cubed minus 2x minus 1. Determine the stationary points. Determine the stationary points. Now, we look for the stationary points, and we can start with y is equal to, the equation is x cubed minus 2x squared, then minus 1. So we look for dy dx. So dy dx, we shall have now 3x squared, then minus 4x. Minus 4x. And we know that dy dx, so dy dx here is equal to 0. Taking, we have 3x squared, then minus 4x is now equal to 0. So we find the values of x. So x will be equal to 3x minus 4. X into 3x minus 4, which is equal to 0. Then x will be equal to now 0. Then 3x minus 4 goes to 0. And we shall now have 3x is equal to 4 divided by 3. So x is equal to 4 over 3. And we have y is equal to x cubed minus 2 into x squared minus 1. So we shall have x is 0, so 0 cubed minus 2 into 0 squared minus 1. So we shall have y to be equal to minus 1. Then we have our y is going to be equal to 4 over 3x. That is the value of x when x is 4 over 3 squared minus 2 into 4 over 3 squared. So this one is cubed, sorry. Then this is squared, then minus 1. So our value of y becomes negative 2.185. So the points now, the stationary points will be 0, -1, 0, -1, the 0, and -1. And that is now 1.33 and negative 2.185. So we have this x and this y. So you have 4 over 3, which is the same as 1.33. Then, and y is negative 2.18. So these are the points. So the stationary points are 0, -1, this one, and then 1.33 and negative 2.185. So that is how you get your 4 marks for finding the stationary points. Then the nature of the stationary points in A above. So we have to draw the nature using, we can have x. Then our x is -1. We have 0. Then we have 1. Okay. So we have dy dx. Then we have the representation. So dy dx, we have it as positive 1. We have 0 to -1. So representation 0, it is that is how 0 is. Positive is represented with this, the negative represented by that. So that is how we represent the given stationary points. Then on the other hand, we have this one. So we have x. So x, the first x is 1. Second one is 1.333. And then we can take 1.5. So x, so we have dy dx. So we have -1, 0, then 0.75. Now, a representation, diagrammatic representation. So 0, this is how 0 is represented. And then this is a positive value. So it appears that way. Then negative the other side. Yes. So that is how we represent this one. The 2. Now in this case, this is maximum, then this is minimum. Maximum, then this one is minimum point. Then we move to B, determine 1, the equation of the tangent to the curve at x is equal to 1. So this is when x is equal to 1 and at x is equal to 1. You know the equation. So we represent x with 1. So we shall have 1 cubed minus 2 x squared, which is 1 squared, then minus 1. So we shall have 1 minus 2 minus 1, and that is how we arrive at negative 2 as the value of y. So the coordinate becomes 1, negative 2. So that is how we find the coordinate. Then we look for the gradient function, and gradient function. So the gradient function dy dx is equal to 3x squared minus 4x. Now, at x is equal to 1, we now have dy dx to be equal to 3 into 1, that is 1 now, x squared, now minus 4x, that is 4 times 1. 4 times 1. That is how we arrive at 3 minus 4, which is equal to negative 1. It is now the value of so negative 1. So that we now use the 3. Now use the 3. We have x, y. We have the point 1, negative 2. And then we have the gradient to be negative 1. So we can form an equation. Changing over, change x equals to negative 1, which is the gradient. So we have y plus 2 over x minus 1 goes to the gradient, which is negative 1, equals multiply. So we shall have y plus 2 equals to negative 1 into x minus 1. So y plus 2 is equal to negative x plus 1. So that y now becomes negative x plus 3. Negative x plus 3. So that is how we find the equation to the tangent and the curve x is equal to 1. Then the last part, the equation of the normal to the curve at x is equal to 1. So you know that m1 times m2 gives us negative 1. And m1 is negative 1 times m2 gives us negative 1. So our m2 negative negative, so it will be now positive 1. Stop recording. Sasa alafu ukifinya hapo kuna stop recording, alafu urudi tena. Naweza kustop recording na kuja kufinya. Yeah. And that is when I sawa. Okay, we can continue. So our M2 is 1. So 1, we have 1, -2, and then xy, then we have our gradient 1. You can use this to now find the equation. So we have x plus 2, changing x gives us the gradient. Now x minus 1 gives us 1. Cross multiply. Cross multiply. Cross multiply, you say y plus 2 is equal to x minus 1. So y will be equal to x minus 1 minus 2. So that you get y to be equal to x minus 3. And that is how we find the equation of the normal to the curve at x is equal to 1. So we move to the next question. The next question is on graphs. The table below shows the values of x and some values of y for the curve y equals to x cubed plus 2x squared minus 3x minus 4. For the values of x running from -3 to 2. Now, you are asked to complete the table. So using the equation when x is -2, you are going to get here to be 2. When x is 0.5, -0.5, you're going to get -2.1. Then when x is 1, y is -4. When x is 1.5, you're going to get -0.63. That is how you get your 2 marks. Then on the grid provided, draw the graph of y equals to x cubed plus x squared minus 3x minus 4. Now, using the scale of 1 centimeter to represent 0.5 units on x-axis and 1 centimeter to represent 1 unit on the y-axis. The y-axis. So this is the graph book or paper. We are now supposed to draw. We're supposed to draw. So remember, 1 centimeter for a y. So we can draw the x-axis. We have 0.5. So this is 1, this is 2, 3. This is x-axis. And then we have -1, -2, -3. 1 centimeter to represent 0.5. Then here we have 1, 2, 3, 4, 5, 6. Then you have -1, -2, -3, -4, -5. Now, when x is -3, y is -4. So -3, -4, yeah. Then we have negative 2.5, negative 0.4, negative 2.5, negative 0.4, it's somewhere here. Then we have negative 2, 2, negative 2, 2 here. Then we have negative 1.5, 1.6, 1.6. Then negative 0.5, negative 2 point, that is 2.1, negative 0.5, 5, negative 2.1, negative 2.1 is somewhere here, 2.1, somewhere there. Then we have 0 for negative 4.0. Then we have 0.5, negative 4.9, negative 4.9. Then we have 1, negative 4. We have negative 4. And then 1.5, 0.63, 0.6, sorry, negative 0.6, that is 1.5, negative 0.6. And then lastly, 2 is 6, 2, 6 here. So we can draw the curve. We can draw. Draw the curve. We're going to draw a smooth curve. Smooth curve. So starting from here. Okay. That is how we draw the curve. Have it now. So you should be having something close to that. So use the graph to solve the equation above. So the equation above, you simply look for the points where the graph is cutting at x, these 3 points. So that will be our answer. So x will be equal to, now here it's negative 2.4. Then we also have x is equal to, this one is 1. Make sure it's negative 1. Then x is equal to 1.6, where the curve cuts the x-axis. So those are the answers solved. Now estimate the coordinate of the turning point of the curve. Now to get the turning point, turning point. We are asked to estimate. So we shall take negative 1.8 and 2.2. And then we also have another turning point. We have 0.5 and negative 4.9. So we shall have this one plus or minus 0.1. We also have plus or minus 0.1. Those will be the correct answers for our question. Then we move quickly to the next question, which is question number 21. Question number 21. Three variables P and Q are such that P varies directly as Q and inversely as the square of R. When P is 9, Q is equal to 12, and R is equal to 12. Find P when Q is 15 and R is. So they're saying that P varies directly as Q and inversely as the square of R. That is what they mean. We introduce the equal sign so that we introduce a constant K Q over what? R squared. So that when P is 9, so we find the value of K, so that Q is 12 and R is what? 2. So 2 squared is 4. So K is equal to 9 times 4 over 12. The value of K becomes what? 3. That is the value of K. Then we find now the equation, find P. So to find P, we simply take K, which is 3, Q over R squared. R squared. So this will be 3 times 15 over R squared, which is 5 squared is 25. So P will be equal to 1.8. That is how simple it is. That is how simple it is. Now you express Q in terms of P and R. That one is simple. So P, we found that P is equal to KQ over R squared. So express Q in terms of P and R. That is now P. Then R, that is now P. Now Q. So that Q, we now have to express Q. So Q will be equal, we are making Q the subject. So Q will be P R squared over K. So that is how we express Q in terms of P and R. Now, the last part of Roman 1, if P is increased by 10% and R decreased by 10%, find a simplified expression for the change in Q in terms of P and R. We know that P1 is in increase by 10, so it's 10 over 100 now times P, which gives us 1.1 P. Then R1 is 0.9 R, that is reduced by 10%. So to get Q1, we have to get 1.1 P, value of P, times 0.9 R squared. But we divide by what? Divide by K. Now, This one will be equal to now 1.1 p times 0.8 1 r squared. Now we divide by k, so that q1 will be equal to now 0.891 p r squared over k. And that is how we express the new q in terms of p and r. Now, lastly, the percentage change in q, percentage change. So percentage change is equal to, we shall take q1 minus q0 divided by q0 and then times 100%. That is how we're going to find the percentage change. So this one gives us now 0.891 p r squared k minus p r squared over k. So that we take now 0.891 minus 1 times, now we have p r, subtract p r squared over k. Now all of it we divide by p r squared over k times 100%. So our final answer going to get negative 0.109 times 100%. So we're going to get negative 10.9%. So that means Q, it decreases. It decreases by 10. The negative means it is decreasing by 10.9%. So that is how we finish that question. And we get our last two questions, our last 2 marks, adding or summing up to 10 marks in the question 21. We move to question 22. Question number 22. Question number 22. A point A is -1, 8, and B is 8, 2. Now this is a question on vectors. Now find the vector A, B. So this is simple. It's going to be simple. You simply find vector AB. Now to find vector AB, you are simply going to take B minus A. And B is 8, 2 minus A, which is -1, 8. -1, 8, and we're going to get 9, -6. So that is how we find, or we get our 2 marks. Then find magnitude AB. Now we find the magnitude. Now to find the magnitude, now we shall find the square root of 9 squared plus now -6 squared. -6 squared. So that means we're going to have 6.708. So that is 81 plus 36. The square root is the square root of 81 plus 36. We are going to get 6.70. Now, we get our 2 marks. Get 2 marks. We move to the next one. Given that a point P divides vector AB in the ratio 1 to 2, find the position vector of point P. Position vector. So point P, it is divided in the ratio 1 to 2. That means P is, the total ratio is 3, so it's 1 over 3. And that is 9 what? Negative 6. 9, negative 6. So when you multiply by a third, that is the ratio 1 to 3, that means we are going to have 3, negative 2. 3, negative 2 as P. Now, on the other side, we have negative 1, 8. Negative 1, 8 now plus 3, negative 2. 3, negative. We have P, and we take the other one. Negative 1, 8. This one for A. Negative 1, 8. So we add the 2 with P. A plus that P. We are going to get now 2, 6 as our answer for that. Then we get 2 marks. Then D, another point R has coordinates 11, 0. Show that point A, B, and R are collinear. So you're having another point R, which has the given coordinates. Now you find show that they are collinear. So point A, we have negative 1, 8. We have it. Point B, we have 8, 2. Yes, we've been given. Then R, we are also given R as 11, 0. Now, A, B, now vector AB will be equal to B minus A, which we got it, which was 8, 2 minus negative 1, 8. And we got our answer as 9, negative 6, our very first answer. Now, we look for vector BR. That was AB. So to get BR, we take R minus B. And we shall have 11, 0 minus 8, 2. 8, 2. And we shall have, we're going to get 3, negative 2. 3, negative 2 as vector PR. Now, we can compare the two vectors. We have vector AB and PR. Therefore, we can see that AB, vector AB is, what is AB? AB is 9, negative 6. And then vector BR is 3, negative 2. You can see that BR, so therefore, comparing the two, we can see that vector, that is AB, is equal to 3BR. When you take BR, you multiply by 3, you're going to get AB. You can see 3 times 3, you get 9. Negative 2 times 3, you get 6. So it's AB is equal to 3BR. 3BR. So we have a common point. Common point B. Common point B. Thus, the points are collinear. So the points are collinear. So that is how we finish, or we handle that question on collinearity on vectors. Then move to question number 23. The diagram below shows the speed time graph for a train traveling between two stations. The train starts from rest and accelerates uniformly for 150 seconds. If the train then travels at a constant speed of 300 seconds and finally decelerates uniformly for 200 seconds. Given the distance between the two stations is 10,450 meters, calculate the maximum speed in kilometers per hour. So following the given equation, it accelerates for 150 seconds. This is the time. So this is where it accelerates to. So this is 50. 150 meters, seconds. Then they're saying it then travels at a constant speed for 300 seconds. For 300, so plus 300 we shall get. Here we have 300 seconds. Sorry, supposed to dot to have it as dotted. So here we shall have 450 seconds. By here, it will be 450 seconds. Then, and finally, let's uniformly for 200 seconds. So it now decelerates for 200. So from here to here is 200. So plus 200, we're going to get the total seconds is 650 seconds. So this is the total time taken. Now, any other information given? No. So given that the distance between the two stations is 10,450 meters, calculate the maximum speed in kilometers per hour. The train tamed. So that is the distance. Now you can see it is forming a trapezium. And we know that the area for trapezium is half into a plus b. Height. They're asking us to find the distance, the maximum speed in kilometer per hour the train attained. Therefore, they're simply asking us to find the value of the height. So that we have 10,450 is the same as now half into, that is 300 now. This is A, B, A is 300 plus B is 650. Then height, which is not given. So we equate, so we shall have 2,900 is equal to 950 H. And then we divide by 950, divide by 950. So H is going to be 22 speed. They're saying kilometers per hour, so it will be meters second. The speed, sorry, kilometers per second. So that is the speed. Now I have to look for acceleration now. acceleration A is given by V minus U over what? Over T. You know that, so that your V is 22 minus, now U becomes what? 0 over T time taken to accelerate was 150 what? 150 seconds. 150 seconds. So we shall have 22 divided by 150. Therefore, we are going to have 0.1467 meters second. So that is the acceleration. Then the distance the train traveled during the last 100 seconds. So the last 100 seconds, we can now divide it was 200 seconds, so we can divide it into 2, the half of it, so that we have 100 seconds, then 100 seconds, 100, 100. So if the speed was 22 meters per second, that means it's going to be half of it is going to be 11 meters per second. So distance, now we are asked to find the distance traveled during the last 100 seconds. So remember, it was decelerating. So we are looking for deceleration. And it is given by 0 minus now 22 over what? T, which is 200. Now V, remember now here V is 0, then U is 22. So we shall have negative 0.11 meters seconds. Now, A, acceleration is given by V minus U over T, so that AT becomes V minus U, and V will be equal to AT plus U. AT plus U. So we find now the V. So V will be equal to negative 0.11 times 100 plus now the 22 meters per second, so that we have negative 11 plus 22, so that we get 11 meters per second. So that we finally look at the distance which we are asking us to look, which will be given by a half times 11 times 100. So that is the area of the triangle. This is a small triangle. So it will be half AD. Sorry, half times base times height. Times base times height. So we shall have our D will be equal to 550 W. Sorry, meters, sorry. Meters. Meters. So that is now the distance. Then lastly, the last part of it, time the train takes to travel the first half of the journey. Time the train takes to travel the half. So we are looking now for the half journey. Half journey is now going to be 10 450, the total, divided by 2, so that we have 52, 25, 52, 25. So we have a half times 150 times 22, then plus 22 times x gives us 52, 25. So we collect like terms. So we have 1650 plus 22x gives us 52, 25. So 22x is equal now to 3575 divided by 22 divided by 22. So x will be equal now to 162.5 seconds. Now we finish by, it was, we now added the 150 now. So the total time of the first half is going to take 162.5 seconds plus 150 seconds. So that the total time taken is going to be 312.5 seconds. So that one is becoming the final answer for that. And that one now brings us to the end of section 2 of this paper. And before we conclude, I'd like to remind you of Ascending Grades Online School that will be having the December holiday program running from 11th November to 12th December, tackling mathematics and sciences. You are kindly encouraged to enroll to online school through the number that you can see on the screen, 0757019011. Thank you for watching, and thank you for being part of us and following us throughout. You have a nice time. May God bless you.
Nicht